Hi, everybody. I'm back again with another exciting conversation for all you to join me. Joining me today is somebody I met a while ago back at Tech Town, and it's Stefan Sysko. Hey, Stefan.
Hello.
And Stefan is the founder of One6 Energy. And you might be wondering, what are we talking about? Energy? Are we talking about EVs? You know, I love EVs. Kind of, sort of, but not really. It's about clean energy. And I was so enthralled with what Stefan and his team created here in Detroit. Every time I see him, I'm like, what's the update? What are you guys working on? And the last conversation we had, international expansion is happening. So before we go into that, Stefan, help people understand what you're doing with One6 Energy. And there's a buzzword I'm going to use that's not really a buzzword anymore, and that is hydrogen. Break it down for us.
Right. Thank you. Yes. So, hydrogen has been the fuel of the future for many, many years. Uh, Oddly, back around the turn of the last century, early 1900s, in Western Australia, hydrogen was being used to heat homes.
Hmm.
So it's actually been used for a very long time. Well, it hasn't been used since then, but they were actually using it. And yet we still call it the fuel of the future. It remains that. And here we are in 2025, still calling it the fuel of the future. And it's because hydrogen is a tricky little molecule. It doesn't like being alone, and
Mm.
it's very hard to get it and keep it all by itself. And, tricky translates to expensive, really. So, uh, hydrogen is extremely versatile. It's extremely clean. When you combust hydrogen, the only exhaust you get, if you were running a hydrogen vehicle, the only exhaust
Hmm.
you get is water vapor. So if you're caught in traffic and surrounded by nothing but hydrogen vehicles, the air is completely clean. And in fact, you're probably just being hydrated. So it is the fuel of the future, but it's also the future. And so my co-founder, who's a former NASA engineer with Jet Propulsion Labs,
Well,
has been
well, hello.
thinking about this. Yeah, he's been thinking about this for a very long time, and thinking about why hydrogen comes right now in two flavors, uh, either cheap but really dirty,
Hmm.
or clean but really expensive. So right now, 95+% of the hydrogen produced in the world is done using steam methane reformation.
Okay.
And basically, you're producing 11 tons of CO2 for every ton of hydrogen you produce. So when I tell you hydrogen is clean, it is, but the production of it using this method is not. And it, so people are trying to do carbon capture and storage.
Okay.
And so the original is called gray hydrogen. That's how hydrogen is produced nowadays. There's the hydrogen rainbow,
Hmm.
where everything's gotten a color classification. Excuse me. That's gray. And so carbon capture is methane reformation with carbon capture and storage. That's called blue hydrogen. There have been studies showing that the capture isn't that robust. They're not able to capture very much hydrogen or very much carbon. The studies I've seen are showing about 30%. Now, I haven't seen all the studies. There may be some better, maybe some worse, but it has increased the costs. So that makes it not as cheap, but still pretty dirty. Then the other side of the coin is the clean-ish, but really expensive. That's termed green hydrogen,
Hmm.
and that's electrolysis. That's when you take water and you actually turn water into its component parts, H2O. You turn it into hydrogen
Right.
by breaking the molecule apart. It takes a lot of energy to do so. And in fact, it takes a lot of electricity to do that. It takes 7 times the electricity as a process like methane pyrolysis, uh,
Gosh,
to
it's
to do that.
when you mention electricity, it's the theme of needing electricity, as you know, right now with AI and computations. It's interesting that there's hydrogen, breaking the molecules apart, and then separately we talk about data warehouses and what's needed to compute from an AI perspective. Then there's another thing that comes to mind to me with energy, and that's Bitcoin, and that's crypto
Yeah,
and
yeah.
blockchain and how that uses energy, and that seems to be this interesting common theme across. So with OneSix, are you all focusing on the green element in terms of the production and breaking things apart?
Absolutely. So with green, see, green's kind of a loaded word for me because they're using green for electrolysis.
Mm,
To be called green, this process needs to get their electricity from green sources. So wind, solar, hydroelectric, which really what it's doing is taking green electricity off the grid.
uh-huh,
So you created a wind farm, a solar farm, and now you're producing green energy, and you're taking that and you're converting it to hydrogen, but at an efficiency loss. So I believe that you're only producing about 45%. There's a 55% efficiency loss. So you're taking green energy off the system and turning it into hydrogen. So there's that. You're also consuming a massive amount of water, of
yeah,
fresh water. And if you look around, the world does not have fresh water to spare. And
nope,
because green hydrogen is still 3 to 4 times more expensive than we need it to be, uh, they're locating these plants in areas where solar and wind are cheap, which just so happen to be areas that are drought prone and are
okay,
the least capable of providing water. In fact, I
wow.
read a statistic that 40% of all planned electrolyzer projects are in drought prone areas. So there are some challenges with green hydrogen. Now, the electrolysis will be huge. It still needs some work. Eh, but for right now, it's got its challenges. And so when you're talking about green, yes, we had a study done, an independent study of our process that shows that we have a very low carbon intensity and we are the cleanest hydrogen production method available right now, even cleaner than green hydrogen. The only one that is in the ballpark of ours is electrolysis using nuclear as the power source. And, small scale nuclear is still a ways away. So, that's not going to be an issue for a little while yet. But even so, we don't consume any fresh water in our
So that's
process.
what differentiates you guys. So what differentiates OneSix from a hydrogen perspective, hydrogen producing perspective is categorically it's green, but your methods, your special sauce, if you will, is one in that it does not use fresh water. Would that be an
That's
accurate
correct.
statement?
That's
Okay.
correct. Yeah,
And
our
that's your
feedstock our feedstock is natural gas. And so one may say, well, natural gas is pretty dirty. Much like electrolysis takes water and makes it not water anymore, we
Mhm,
take natural gas and make it not natural gas anymore. We decarbonize natural gas. And so we take the methane or
mhm,
natural gas molecule and we turn it into hydrogen and carbon black. But because we do it in the absence of oxygen, we don't create CO2. We create solid carbon, carbon black, which is a valuable resource that is used in many industries, in rubber, in plastics. In fact, excuse me, if your car tires didn't have carbon black in them, they'd probably fall apart in 8 to 10,000 miles. Uh,
Okay, so pause for a second for the layperson watching this, because this fascinates me. For those who
Sure.
know me, I'm such an inquisitive person. So that's and I knew about what you were doing, but you just mentioned something to me that's also pretty cool. You're not only make sure I have this right, you're not only producing it vis-a-vis a green method, it's your own special sauce where you're converting natural gas. Another output is not just hydrogen, which I want to talk more about that for people watching about the benefits of that, it being clean, so on and so forth, powering cars, other things, boats, so on and so forth. There's another byproduct, which is carbon black. So it's
Correct.
almost like a twofer.
Correct. Carbon black is a co-product. In fact, we produce a great deal of carbon black, and there is a huge market for it because in on top of rubber things, plastics,
Mhm.
electronics, in your Kindle, the words in
Yeah,
your Kindle are carbon black. The water filters, your Brita water filter, um, inks, toners. Um, Carbon black is everywhere. Automotive interiors, the hoses in your car, the soles of your dress shoes, um, my shirt, everything. So much stuff has carbon black in it. It's a huge market, and so our process, the process itself, is actually something that's very uh, well known. It's methane pyrolysis, but even that we've changed.
mm,
Again, as a NASA engineer, my co-founder Dan has learned to make things extremely simple and extremely reliable. If you think about it, everything he designs or helps design, I guess would be more accurate. Um, Once it leaves the launch pad, it goes out in space and you can't tweak or fix anything.
yeah.
So making it simple, making it reliable, not to mention it costs a great deal of money for every kilogram of weight that you put into space. So people come in and say, we need to add this feature, this functionality to the thing you're designing. And he has to figure out how to add that without adding any weight. And so he very much did the same thing with hydrogen production and sat down and thought, well, here's one way to do it. Okay, well, what are we trying to achieve? And
Mhm,
what are the different methods of achieving that? And much of methane pyrolysis has been worked on by chemical engineers. He's a
mhm,
mechanical engineer, and that shows through the design work throughout our product. And so methane pyrolysis involves typically catalysts, things like molten iron, molten nickel, which is not only something I don't want to work with, but also difficult to scale, or plasma. So extremely high temperatures, exotic materials, etc. And we've eliminated all of that, all of the complexity, driven out the cost, both in operating expenses and in capital expenditures. And so what we've come up with is extremely low cost. The US Department of Energy some years ago set out that by 2030, the goal was to be able to produce hydrogen at $1 per kilogram.
mm,
And industry kind of rolled their eyes and said, that's, good luck with that,
yeah.
producing clean hydrogen that way. And we are extremely close to that number.
Wow.
And so we're pretty excited about that. Our prototype is in Missouri right now as we speak. This morning, just had a 2-hour phone call with the team down there, the Missouri University of Science and Technology. They're running all the tests, to make sure it's all validated and that it all works the way we expect and the way we've been saying that it's going to work. So far, the results have been good, but we'll find out in about a week, maybe a week and a half. Uh, and after that, we're launching our seed round. So probably mid-November, we'll be launching our seed round.
Well, that's a lot of development in the last few months since well, it's like not months, but years since we spoke about this. A couple questions come to mind. First, how did this whole concept come up? Because were you like, hydrogen. Like, what was the motivation for how this came to be and how you and Dan partnered up?
Co-founder, it actually started with him,
Mhm.
and I guess it was 2003. He was working for General Motors at the time in their medium trucks division. And medium trucks aren't known for being that clean.
Right.
But he had been given a book about the hydrogen, I think it was called The Hydrogen Economy.
Oh,
And he started reading this book, and he walked into his wife and said, "This is incredible. I never realized this." And uh, he said, somebody has to do something about it. And I don't know if anybody's doing anything about it. So I think it's got to be me. And that was kind of the moment he
well,
decided he wanted to really dedicate his time, talent, and efforts to helping, with climate change. And the next day, he went into the office and did a little research, found out that there was a job opening in Honeoye Falls, New York, in their fuel cell division. He called up, applied, and got the job, picked up, and moved out to New York with his wife and his young son. I think his son was an infant. I think he was maybe one, but um, and moved out there and started working on fuel cells.
wow.
Some years later, GM was going through or getting ready to go through bankruptcy, so he, as he says, left for the safety of a Silicon Valley startup and
Mm,
worked for a solid oxide fuel cell startup, which did hydrogen production only in a not clean way.
mhm.
And that's when he started thinking about certain things that ultimately became elements of One6 Energy, and how to clean up the process. And when he joined NASA and Jet Propulsion Lab, he learned how to take things from idea to
Got it.
launch into space. And so he really learned the things he needed to know about taking this idea and figuring out how to make it happen. And so fast forward about a decade, uh, Dan's wife and I had gone to high school together. And so we had kept in touch a little bit
Mm,
over the many years in between. And and I kind of got to know Dan a little bit. He was working on a writing project, and through Facebook, I kind of said, "Well, I'll help you out a little." And so we got to know each other a little bit better, throughout that process. And one day we were on the phone, and he said, "I've had this idea. I've been thinking about it for 15, 20 years, and if I don't do something about it now, I never will, and I'm going to kick myself if I don't. I have no idea. I know nothing about business, so I don't know what I'm going to do, but it's going to kill me if I don't do anything."
wow.
I said, "You do know what I do for a living, don't you?" He says, "Oh, not really." I said, "Well, I kind of start businesses and, grow businesses and help other people grow businesses." And he said, "Well, I'll be in the Detroit area next week, visiting family." So we got together in the lobby of a hotel where they were staying, talked for a couple hours. And I got home and said to my wife, "I think I have one more startup left in me." Um, because it's not very often you get an opportunity to genuinely change the world. And so I called Dan a couple days later and said, "I'm in." And
Wow.
yeah, and that was it. We started, talking every day, planning some things out. We incorporated in February of 2024, and it's kind of been a heck of a ride since then. We've, uh, we bootstrapped with founder funds, and
Mhm.
then earlier this year in 2025, we raised a friends and family round
Mhm.
because it's not software. We needed to build a prototype, and that was going to cost quite a bit of money. And so we raised enough to build the prototype and to test it. And so we did that, uh, throughout this year,
Mhm.
and over this fall, we had the prototype produced, and then we assembled it at a warehouse on 23rd Street in Detroit, through New Lab. We're headquartered at New Lab.
Mhm.
And so we built it, we put it on a flatbed truck and drove it down to Rolla, Missouri. And the professor doing the testing is somebody Dan had worked with some years ago. And it turns out he's got almost 40 years of experience in exactly this kind of thing, in methane pyrolysis, in combustion, in carbon. He's worked for Dow and for Cabot Carbon and for some of the big companies, and probably knows at least as much as anybody in the world about this process. So he and his team have been great to work with, and we're right now. My end of it is I'm working. Excuse me. I am working to put together our data room, and also working with folks around the world who are interested in becoming pilot customers. And
Yeah, I wanna talk more about that, about the global piece of the business, because that's what's intriguing to me because we obviously live in a global world. But going back to what you said earlier about the way that the company started, I really love hearing the stories of people who are founding companies and they have ideas, but those ideas were something that the idea, for Dan was ruminating for quite some time. And I think this is really motivating. Now, are people watching this gonna make a, hydrogen startup? Probably not. But I think the important nugget out of this is the combined experiences of what you guys bring to the table that was massaged for many years. Dan seeing the writing on the wall with what he was interested in. He's flipped jobs, went to do fuel cell work, and then he saw the writing on the wall with GM at the time. I know sadly there's been some GM news this week as well, but
whereas,
he, shifted, and it's just so remarkable to see how that, we talk about life and knowing what you know, but also who you know. How interesting is it that you went to high school with Dan's wife, you kept in touch, you guys merged skill sets, and here we are. And now he happens, to have the additional experience with the Jet Propulsion Lab. It's remarkable, and you have this technology. And the last time we spoke, we were talking about, your global presence. Now, of course, if someone's in the industry, like they know, the hydrogen space, I'm assuming isn't like a big network. I mean, there's people interested in it, but it's not like you've got a bunch of crypto people around the world. I'm assuming it's got to be a smaller type of club. So you're working on this prototype. How are you? How are you, reaching out and, "Hi, we're building this hydro," which how are you, it's so niche and it's so important. How are you reaching out and getting people to understand that A, you exist, and B, they should give your product and your technology a whirl?
it's, I guess, relatively speaking, but it's a lot bigger ecosystem than you would believe, than I believed. We attended the World Hydrogen Congress in Rotterdam, in the Netherlands, uh, earlier this year. And it is not small. And when I went out looking for other hydrogen events to go to, I could just pack my bags, leave, and not come back,
Wow.
just going city to city. The conference in Rotterdam, I can't remember. I believe it was 20,000 attendees. There were hundreds of booths. It was insane. Uh, in fact, if you go to the Netherlands, we talked to them about, so what do you have going on in hydrogen? And they pretty much asked, well, what would you like to know? In the north, the northeast, the northwest, the southeast, the south, because we've got different projects going on in different areas of the country. And it's kind of crazy how much they have going on. but not to be denied, Scotland is very much the same. I could go on and on about countries in Europe who
Well,
have many
let's pause
projects going
let's
on.
pause there because again, this is intriguing to me. And you can be very neutral. I do think it's great that we live in a global world, that there's fiber in the oceans letting us connect and talk to folks around the world. Would you say that our counterparts in different parts of the world and other countries are ahead of us when it comes to thinking about this technology and incorporating it into their daily flow of running companies, business efficiency? What would you say the delta is between that?
So I don't know about thinking, but in terms of implementing, yes, there is a lot going on around the world when it comes to hydrogen. Uh, there are I get news every day of new projects, being started,
Mm,
uh, but also in just the contacts I've made over the last year around the world. Uh, there are uh, there are there are a lot of projects that are either ongoing or that have started, but also kind of the other side of that coin is again, electrolysis has been the savior.
right.
It's all about green hydrogen. Uh, in fact, I would love for people to stop saying the future of green hydrogen and start calling it the future of clean hydrogen.
Ah,
Because
fair.
green has become the default, and that's tied to electrolysis. And over the last 6, maybe more months, I've started seeing more about, well, maybe it's not the answer. And again, I'm not going to say it's not the answer or one of the answers. What we've learned is there's not really as much competition as there is bring everything on, and it's still not going to be quite enough, right?
Yeah.
So electrolysis has a place. It's going to be huge. There are issues. It needs to come down in price. There's the water issue. There are issues. People will figure them out, and it will be a major component in the hydrogen economy. But we need all the options in order to successfully transition the world to a clean fuel economy. Uh, the the challenge that I've seen now that people are starting to realize, well, we can't afford this. We can't quadruple our costs
Mhm.
and switch to hydrogen. Is many hydrogen projects are being canceled. There have been hydrogen auctions around the world where the winners of those auctions have backed out, and the UK has just guaranteed astronomical prices for hydrogen. That kind of thing can't last. The hydrogen market globally is about a $300 billion a year market. Only 18 billion of that is expected to be clean hydrogen. And near as I could tell, that's basically the subsidized portion. The other $275 billion is dirty hydrogen.
So for someone who they may have heard, I think people are hearing about hydrogen more. Can you give folks some practical examples of how this technology can be used in current systems? I know we talked at one point too about ports, and you were looking at partnering with different ports around the world. Give us some examples of today how somebody can understand what the technology can do from a clean energy perspective. What
Sure,
applications?
sure. So people immediately think about hydrogen cars.
Yeah.
Hydrogen cars are great. They exist. There's a Toyota Mirai, which there are people who drive one, mostly in California,
Mm,
because that's the only place in the US there are hydrogen fueling stations, and
'kay.
there really aren't many of them. Uh, BMW announced last year that they will be rolling out a hydrogen passenger vehicle in Europe in the 2028 model year. That's really soon in terms of automobile model years.
Yeah, especially with the and what makes me you I paused in my brain when you mentioned Cali, which makes sense, but then there's also hydrogen fueling stations another pause in my brain because some folks argue, I don't know if I'm there yet, that we need more electric vehicle stations. So then I wonder, what by the time hydrogen comes around, but then you mentioned Europe. So have you seen in your experiences and travels in Europe that they have less of an issue getting hydrogen fueling stations built and going?
They
And
have an issue. There's more. There's more of them, but in no way are there enough.
okay.
But they have more, and as I understand, they have plans to add more. But it's still an issue, much like EV charging stations some years back, right? So it'll come, but well, excuse me, hydrogen passenger cars aren't the immediate future. Maybe we can do this backwards. So
Mm,
closer than that would be Class 8 trucks,
got
semi,
it. Got it.
right? The major corridors across the US
Yeah.
where you can basically set up a dozen hydrogen fueling stations east to west across the US and take care of a significant percentage of truck traffic coast to coast,
Mhm.
and then start going from there. There's a plan by the Department of Energy and Department of Transportation to start making that happen. But if you think about electrifying trucks, semis,
Yeah.
takes a lot of power, so you need a big battery.
Oh, yeah.
Batteries are heavy.
Mhm.
You get a big battery, you need more battery because it's so heavy. Eventually, you get a big enough battery, it just difficult, right? Because you don't want to start creeping into the load that you're able to
Yep.
carry. So you need these big batteries, and then one of the rules we kind of were thinking about as we were starting the company is that if you're making money while you're driving and not making money while you're stopped, that's a good need for hydrogen.
Interesting.
And if you're a long haul trucker, every time you need to stop and recharge, and charging times are getting shorter, sure,
Yeah,
but
but still
hydrogen fueling times are the same as diesel fueling. You stop, you fuel, you go. You don't have to plug in and wait. So
I
so
didn't know
for
that.
yeah,
That's cool.
it's the same as gassing up your car. So so Class 8 trucks, Class 7, uh, distribution centers, anywhere there's a hub and spoke model where delivery vehicles are
Mhm.
leaving, going around and coming back. They can refuel at the distribution center.
'Kay.
So post office, UPS, FedEx, Amazon. If you can put a fueling station at your center, leave, come back, and refuel without having to plug in and wait. So that's in terms of mobility. Ports are huge. There are ports where certain ships can't come unload, and so ports lose business because those ships are too polluting. And apparently ships can't just shut down, they need to idle.
Yeah.
And so now ports are dragging these big electrical cables out to ships in order to get them to come into their ports and not pollute, but that's really expensive. They want to be able to use hydrogen to help do that. They also have a lot of really big equipment that moves pallets and shipping containers around. Switching those over to hydrogen will help them out a lot. So ports are a really big customer, a potential customer of ours. Um, but then you get into industry, into
Mhm.
heavy industry. Petroleum refineries
Yeah.
are huge. They use several hundred tons of hydrogen a day. They're huge users, but it would help decarbonize a lot. It would be really helpful for the environment to switch them to hydrogen. The other biggest user of hydrogen is ammonia production facilities. It would surprise me too, but it's in the production of fertilizer, so it makes sense. They also use a lot of hydrogen in their process. Then there's steel mills. We actually had a call from an operator of steel mills, and they've developed a way that they could do their iron ore reduction using hydrogen. And so they're talking to us about can we provide that hydrogen? And again, they use a lot of hydrogen per day. So we're very modular. And right now we're focusing on a 1 ton of hydrogen a day unit as our initial product.
That's what I was gonna ask because every category and industry you're talking about, whether it's vehicles, you're talking about ports, you're talking about refineries. I know that you are an OG Detroiter. We also talked about a couple weeks ago when you were growing up and, seeing the plants and seeing the smoke coming out of the different plants and whatnot in the factories downtown. I'm sure that wasn't so great for the environment. No shade to the big 3. We know that's how it was back then. But how are you so you're having this technology. You have this technology to better produce this hydrogen, so it's carbon black and it's truly green. And the crew that's testing the apparatus down in Missouri, and you just said 1 ton, and this is again, this is just my naivete in terms of understanding how things
Sure,
work.
sure.
Over time, is it a ideal state whereby you guys have different things you've built that could then like my vision is like a refinery. Would they then take one of your things you build and stick it there? You mentioned the ports in the Netherlands. You'd have this thing built by One6 Energy they'd use to facilitate their hydrogen
Yes,
creation, correct? Got it.
exactly. So all we need really is a natural gas pipe like you have in your
Yep.
kitchen or laundry room.
Yep.
We plug into, we plug the pipe in and we run our equipment, take the natural gas that, at least in the United States, is pretty ubiquitous,
Hmm.
and we convert that. And the
Wow.
carbon, we use, our equipment goes into two 20-foot shipping containers,
Okay.
and they're stacked one on top of the other. And then there's a hopper, a silo that goes kind of on the side. The carbon black gets augered up into there. About once a week, a truck comes up underneath the silo, the hopper, drops the carbon black in, takes it away for processing. And meanwhile, the hydrogen just gets pumped wherever it needs to get pumped. So that's another benefit is we're on site. Transporting hydrogen is incredibly difficult and expensive. In fact, the research we've done, the transportation costs are probably higher than the manufacturing costs.
This is just such
It's
a feat.
it's a very small molecule. It likes to get away. It's hard to contain it. It's under pressure. You need to pressurize it. It's difficult to transport. And there are companies who specialize in it,
Sure.
but it's still going to be more expensive than park it right outside your oil refinery, run the hose, as it were, uh, right in and use it right in the process.
This it's just so incredible to hear how this built and built over time, and it's obviously an issue. It's a challenge that you're solving, and I love what you mentioned about Dan early in his story when he went to his wife and he said, "No one's doing this right now. Why not me?" I know it's cliche when we talk about, these founder stories and inspiration, but I wanted to talk to you too because I think it's so important for people to understand that regardless of age, you told your wife, "I've got one more startup in me." I just think that's so crucial because you have such depth of experience building things, and I'm sure you made a boatload of mistakes with other things you've started or other businesses you helped grow, and you're taking those learnings and applying it here to potentially speed certain things up or do certain things more efficiently. I think that's great. And you're at this stage now. So you mentioned at the beginning of the call, today you are raising a C round. You mentioned is that still that's accurate? And
Yes.
what do you guys foresee in the next like 6 months of the biz, or what are your whether it's goals or your roadmap? What can we anticipate seeing from you guys in the next 6 months?
Yeah. So in the next 2 weeks, we'll have the results and the validation of the technology,
Mm-hmm.
or for the seed round.
Mm-hmm.
Um, Things in the VC world tend to slow down a little bit around the holidays,
Yeah.
but we've got a few weeks before then, hopefully to generate some excitement. We've already talked to a lot of VCs and corporate VCs. We've gotten a great deal of interest among some strategic partners. And So the hope is we start 2026 strong in terms of talking to CVCs or VCs and close around Q1 of next year, at which point we start hiring a bunch of engineers and some other folks, and start building our designing, integrating, building our pilot unit,
Got
and
it.
that'll be the half ton to 1 ton unit. That ought to take probably about 18 months.
Okay.
In the meantime, we'll sign more binding agreements with pilot customers, paid pilots, and once we get that single pilot unit built, at that point we'll build hopefully 3 to 5 more and run 3 to 5 paid pilots, and after that we go commercial. So we're still a ways away,
Sure.
but the next 18 months should hopefully, all things go well, take us to pilot, and that'll be the hopefully the kickoff.
Well, that's tremendous. It's so, and where is Dan physically located now? What is
So
he?
Dan,
Well, he's in California.
he is here in Southeast Michigan.
Oh, he is.
Yeah, so Dan he grew up in Milford, Michigan. He took off over 20 years ago. He was a two-time University of Michigan graduate in their aerospace program, and once he left GM
Mm-hmm.
here,
Yeah.
he lived on the coasts for over 20 years. And, once we incorporated, I brought him back to Detroit. So, there's a lot of talk in Detroit about, the engineers that graduate and leave and bringing them back. And so I'd like to think I contributed by bringing a NASA engineer back
Yeah.
home to Detroit.
That's huge. I'm a boomeranger. I came back, but I'm not a, a NASA engineer. But the story, that's true. I didn't realize that he was back here physically too. So, to wrap that part of the story up, which I think is amazing, why I'm also having these conversations with founders and makers and doers in Michigan and the Midwest, especially in Michigan, it is so great to see other ideas coming to fruition. Yes, this does affect cars and it does help the car industry, but other concepts and startups and technologies and innovations that aren't just around cars, because I think there's so much more we could do and that we are doing. And what you guys are building is another example of that. And Dan, welcome back home. It's so great that we have both of you in the Detroit area building this really cool, badass startup. So Stefan, let me pause that so I can re-edit. So Stefan, what is the best way, someone watching this right now, we'll include links with how to find you, the website, is that good enough in terms of how to reach you? Are there other ways you want them to reach out and get to know you?
Yeah, absolutely. So, checking out our website, and there's ways to contact us there. Following One6 Energy on LinkedIn, following Dan or me, or linking in with us on LinkedIn.
Hmm.
Um, my email address and phone number and everything's on LinkedIn. Uh, Definitely would love to talk to folks who are interested in hydrogen, who are interested in investing in us, or partnering with us. And you had mentioned Detroit. Detroit put the world on wheels, and we think we're the perfect place to now fuel the world.
Oh, that's so good. That's so good. That's so good. Because again, I know that the industry makes sense for ports and plants and refineries, and then we talk about trickle down, not like it's the '80s trickle down theory,
Sure,
but
sure.
for the regular consumer. Because I know you mentioned too when we spoke that you had grown up and you had childhood asthma. I have a child who has allergy-induced asthma, and it can get really bad. Like when I have those indicators of the outside not being great from an air quality
Right?
consistency, no joke, if it's really bad, he'll start hacking. And it's prevented sometimes,
Yeah.
going out and swimming. And a lot of it could be caused, would you agree with, if it's heightened in the atmosphere with
Oh,
what exists in the
absolutely.
atmosphere, that can really affect it. So what you're doing is it is such a good common good cause for folks, and they may not realize it. So thank you for the work that you put into it. and for
Yeah.
the time that you spent, walking me down through the awesome nerdery that is hydrogen. Oh, last question. One6 Energy. Do you want to let folks know about the origin of the name, why it's One6?
Sure. So, periodic table of the elements. One is hydrogen and six is carbon.
There
And
you
those
go.
are our two co-products.
Great. Well, thanks, Stefan. Good luck to you. And I'm looking forward to seeing how you guys continue the next 18 months.
Thank you very much. This has been fun.
Awesome. Bye.
Bye.